Across 200 million miles of darkness, something once thought extinct has awakened. The interstellar comet 3I Atlas, silent, cold, and fading since spring, has just shocked astronomers with new data showing it is active again. Spectral spikes, ultraviolet flashes, and fresh water jets have reappeared, even as Atlas drifts beyond Mars, where sunlight should be too weak to touch ice. NASA's own Swift Observatory registered a sudden bloom of hydroxyl molecules, the unmistakable fingerprint of venting water, from a body that should be frozen solid. Tonight, scientists from Hawaii to Chile are scrambling to confirm what the numbers already whisper. The third interstellar visitor may not be dying at all. It may be alive. At first, no one believed it. The raw data arriving at the Space Telescope Science Institute looked like a glitch, a stray pixel, a calibration drift. 3 months ago, 3I Atlas was fading fast, its coma thinning to invisibility, its water output collapsing to near zero. By all models, the comet should now be dormant, a drifting shard of frozen minerals headed for the void. But on October 12th, the Swift Ultraviolet and Optical Telescope logged an unmistakable surge, 1.3 times 10 to the 27th hydroxyl molecules every second, a signal far too strong to dismiss as noise. Researchers rechecked their archives, stacking earlier exposures. The same pattern emerged, faint, then steady, then spiking again. If the instruments were wrong, every calibration across 3 telescopes would have to be wrong in the same way. And yet, the numbers held. It shouldn't be possible, said Dr. Lila Henders of the University of Arizona, unless the comet somehow reignited. What could wake a frozen interstellar relic millions of miles from any meaningful sunlight? A lingering patch of volatile ice? A crust fracture exposing buried heat? Or something far stranger that none of our equations can yet describe? Every instrument that turned toward Atlas in late October found the same paradox. The comet was venting water and carbon dioxide with the energy of an object half its distance from the sun. Swift saw ultraviolet hydroxyl lines pulse in and out with rhythmic precision, as if timed by an invisible metronome. The Very Large Telescope in Chile detected atomic nickel emission, bright, clean, and unmistakable, but with almost no trace of iron. JWST's NIRSpec followed days later, picking up an unexpected infrared excess, proof that carbon dioxide had once again overtaken water as the dominant gas. Each dataset deepened the confusion. No comet born in the solar system behaves like this, and no interstellar object has ever repeated its activity. In 2017, 1I Oumuamua slipped past Earth bone dry, with not a single molecule of water. 2 years later, 2I Borisov shed dust and vapor like a normal comet, its chemistry almost comforting. But 3I Atlas, this one doesn't follow the rules. It flares when it should fade. It breathes when it should sleep. Teams from NASA, ESA, and the European Southern Observatory compared notes in emergency teleconferences. Dr. Veronika Kubler, who first reported the nickel anomaly, insisted her spectrum was real. Nickel lines blazing, iron lines flat. Others accused her of overcorrection or bad starlight subtraction. Yet reanalysis confirmed the same result. Nickel without iron. 3 words that tore through the comet science community. Some pointed to exotic chemistry, nickel carbonyl molecules breaking apart in sunlight, while tougher iron compounds stayed trapped. Others invoked deep structural layering, a crust rearranged by cosmic radiation, separating metals by volatility. But none of it explains the timing. Why now? Why, after months of silence, would Atlas erupt again from beyond Mars, as if something within it woke up? Tonight, as the world sleeps, the most powerful eyes in orbit will turn toward a single speck of light near the constellation Pisces. NASA's Swift Observatory, ESA's Mars Express, and the James Webb Space Telescope are all scheduled to capture simultaneous spectra of 3I Atlas for the first time since its reawakening. It is not routine. This is a global coordination call issued in less than 24 hours, something usually reserved for supernovae or gamma-ray bursts. The reason is simple. Whatever is happening around Atlas is escalating. Telemetry from ground-based arrays shows its coma expanding at a rate of more than 1,000 miles per hour, its brightness doubling every 6 hours. That's behavior associated with inner solar system comets, not a frozen traveler stranded 3.5 astronomical units from the sun. Swift's ultraviolet detectors have already logged preliminary flashes of hydroxyl once every 2 hours, far too regular to be random. If those pulses repeat during tonight's run, they could point to rotation, vent cycling, or even a periodic release of trapped volatiles. Inside NASA's Jet Propulsion Laboratory, teams are running models around the clock. Some predict Atlas will stabilize, venting until its inner ices equalize. Others warn of fragmentation, that the object could split again, like its namesake Atlas fragments from 2020, releasing a cloud of glowing debris. But a smaller group, quietly, suspects something deeper. That the chemistry driving Atlas's outbursts isn't thermal at all, that it might be electrochemical, energy stored and released like a primitive battery in deep space. If the instruments confirm the periodic flashes, Atlas could redefine how scientists classify active bodies. The term alive would no longer be poetic. It would be technical, describing a self-sustaining system, exchanging energy with its environment across billions of miles. And the control of that data, the raw files, the high-resolution spectra, rests in the hands of just a few institutions. For the next 6 hours, NASA alone will decide what the world gets to see. As midnight passes over Houston and Madrid, 3 competing theories are taking shape, each one more unsettling than the last. Scenario 1, the safe model. Atlas has simply fractured again. A small subsurface pocket of volatile ice cracked open, releasing a brief surge of water vapor that mimics periodic pulses. The rotation of the nucleus could expose and seal these vents in a rhythm that looks intelligent but isn't. Within weeks, the activity will fade, and the comet will resume its long, cold glide into interstellar space. That's the conservative view, the one that keeps textbooks intact. Scenario 2, the dangerous model. Something inside Atlas is unstable on a much larger scale. If the nucleus contains layers of trapped carbon monoxide or methane clathrates, a cascading sublimation event could follow, tearing the object apart. A breakup that, far from the sun, would scatter fragments across a broad heliocentric arc, invisible until sunlight catches them months later. NASA's Planetary Defense Coordination Office has already run preliminary trajectory checks. No collision risk, but potential interference with deep space communications as the dust cloud expands. Scenario 3, the extreme model, the periodic flares, the nickel anomaly, the reversal of water to carbon dioxide ratios. Together, they suggest something more structured, a mechanism rather than an accident. High-resolution spectra show Atlas's outbursts follow a near 6-hour interval, matching its rotational period too precisely for chance. Some researchers whisper, engineered behavior, a phrase once dismissed as fringe. Could an object really modulate its own venting, storing and releasing energy like a designed system? For now, the agencies tread carefully. Extraordinary claims require extraordinary evidence, said Dr. Veronica Kubler in a live briefing, echoing Carl Sagan's rule. Yet even she admits the data feel uncannily deliberate. If Atlas is natural, it's rewriting chemistry. If it's not, the implications reach far beyond astronomy. Social media is already ahead of the scientists. The hashtag #NajuAtlasIsAlive has crossed 2 million views in 12 hours. Amateur astronomers are live streaming the comet through backyard telescopes, watching the pale green coma pulse like a heartbeat against the stars. No one knows what the next frame will bring, but every observatory on Earth is awake to find out. If the data from tonight confirm what early readings suggest, the shockwaves will ripple far beyond astronomy. A reawakening interstellar object changes the foundation of how scientists define activity, chemistry, and maybe even life itself. For decades, textbooks taught that comets are passive relics, frozen archives of their birth systems. Atlas would destroy that certainty. A body from another star, capable of storing energy and reigniting across the void, means that complex chemistry, perhaps self-organizing chemistry, can survive between suns. That possibility pushes science into uncomfortable territory. If the same reaction happens elsewhere, It suggests interstellar space may not be sterile. Microscopic chemistry could drift, react, and restart across light years, bridging star systems with shared molecules. "We may be watching a bridge between lifeless and living matter," said Dr. Anaïs Marron from the Paris Observatory, who first noted Atlas's carbon dioxide dominance. But beyond the scientific awe lies a harder question. Who owns the data? NASA's raw telemetry is encrypted, its public release delayed until peer review. The European Space Agency plans its own publication schedule. Meanwhile, independent observatories argue that discoveries of potential biological or engineered signatures should never be proprietary. The ethics of secrecy in space science are suddenly back in focus. Should information that could redefine our place in the universe be held behind institutional firewalls? There are also practical consequences. Funding agencies will reevaluate comet missions. Instruments once aimed at asteroid mining might now pivot to deep space chemistry. And the next generation of telescopes, Rubin SKA, the extremely large telescope, will be asked to include interstellar watch programs in their first light plans. Atlas could quietly reshape the roadmap of 21st century astronomy, because if a single visitor can awaken this far from the sun, then the line between a comet and something alive just blurred forever. Behind every telescope feed, behind every glowing graph on a monitor, are people running on caffeine and adrenaline. In Pasadena, engineers at NASA's Swift Operations Center have been on 12-hour shifts, babysitting ultraviolet detectors that were never meant to track something this erratic. In Hawaii, a graduate student named Kei Matsuda keeps a live spectrograph running through the night, manually syncing timestamps with the comet's 6-hour pulse. "It feels like watching a heartbeat," he told a local reporter. "If it skips, I notice." In Chile's Atacama Desert, the Very Large Telescope team works under the freezing wind, cycling between exposure runs and hot coffee. Dr. Veronica Kubler, who once endured weeks of skepticism over her nickel data, now sees her inbox flooded with collaboration requests. "For a scientist," she says quietly, "there's nothing more terrifying and beautiful than being proven right by the universe." And beyond the institutions, tens of thousands of citizen astronomers are joining the effort. Amateur observers in Poland, Argentina, and New Mexico have been uploading raw image stacks to a shared server nicknamed the Watchtower. Every few minutes, new frames arrive, proof that discovery is no longer confined to agencies. The story of Atlas is unfolding through a patchwork of human eyes, from billion-dollar observatories to backyard telescopes pointed at the same star field. They are not just gathering numbers, they are witnesses to a moment in history. Somewhere between the technical chatter, the bleary eyes, and the clicking keyboards, a truth sinks in. Something from another star has come back to life, and humanity is watching together. By dawn, the first composite spectra will begin to download. Whether they confirm Atlas's rhythmic pulses or dismiss them as coincidence, one fact will remain. The universe just reminded us how little we understand. For all our telescopes and algorithms, we are still standing in the dark, staring at something breathing across billions of miles. If Atlas truly reawakened, then life, or something like it, may not need planets, sunlight, or oceans. It may only need chemistry and time, a slow pulse of molecules, building, collapsing, and building again, waiting for the next star's warmth to whisper it awake. Maybe this is how life travels, not in spaceships, but in frozen seeds, carried by the currents of gravity between suns. But if the reawakening turns out to be nothing more than exotic chemistry, the wonder remains the same. Every anomaly forces us to look again, to question, to stretch the edge of what we call possible. As Dr. Hender said before signing off her shift, it's not about finding aliens. It's about realizing the cosmos still has secrets worth losing sleep over. Tomorrow, the data will be public. The world will argue, debate, and speculate. Yet, somewhere beyond Mars, a small green glow will keep drifting through the cold, a messenger from another system, quietly venting its story into the void. Because whether it's stone, ice, or something we can't yet name, the universe is still alive.